In this video, we're going to look at revision of differential calculus in stage 1. So we're going to look at rates of change, and we're going to look at the first principles formula. So rate of change is just the ratio between two different quantities. So usually one of these quantities is with respect to time. So often speed is a common rate that we use, speed, acceleration, and speed is just a distance travelled per unit of time. So it might be how many meters you've travelled per second, or it might be how many kilometers you've travelled per hour. So speed is a common rate that we want to find. So we're going to look at different graphs. So constant rates of change. So if there's a straight line graph, this just means that something is changing at a constant rate. So as we have a change in x, so a change in x of 1, we have a change in y of 2. Change in x of 1, change in y of 2. So there's a constant change between this line. So if we were to find the constant rate for the above graph, we could calculate the gradient. So remember the gradient formula. Oops. The gradient formula is, let me just change the pen mode. So the gradient formula is m for gradient is equal to y2 take y1 over x2 take x1. So you can pick any 2 points along this line and calculate the gradient. So I'm just going to pick the point 2, 2, and we'll pick the point 3, 2, 3, 4. So our y, so this is our x2 and our y2. And so that point here, wait, let me put a dot on the screen, and this point here is our x1, y1. So our y2 is 4, so it'll be 4, take our y1, which is here, which is 2, and we're going to have our x2, which is here, our x2, which is here, and this is, our x2 is 3, and our x1 is 2, so it'll be 3 take 2. So our gradient of this line is a rise of 2, so 4 take 2 is 2, and our run is 3 take 2, which is 1. So our slope is 2 over 1, or just 2. So that's for a constant line. We can also look at curved lines. So this is a variable rate of change. This is where it's not changing at a constant rate. So if it's getting steeper and steeper and steeper and steeper, this is actually what we call an increasing rate of change. And it's indicated by getting progressively steeper. So this could be something that's accelerating. So someone that's running, but they're getting faster and faster and faster. Whereas something that's got a decreasing rate of change would get less and less steep. So it might be you've left something out in the sun, it's getting hotter and hotter and hotter, but eventually it's starting to smooth out and reach the temperature of outside. Now, often we want to be able to find what the rate of change is at a given instant, which is what we're going to look at next, which is in an instantaneous rate of change. So in order to find an instantaneous rate of change, just like we did with constant rates, we can calculate the slope. However, now we're going to need to draw something called a tangent at a point. So in this example here, we have a graph of distance versus time, and we want to find the instantaneous speed of the swimmer at 2 points at 30 seconds here and at 90 seconds here. So in order to calculate the instantaneous rate of change, which is in this case is the speed, we want to draw a tangent at this point and then calculate the rise over run, the gradient of the slope. Now I'm not going to do this manually because it's too difficult with the pen, but you can see from this gradient here at 30 seconds, you can see that it's got a rise of 1 and a run of 2. So the speed of the swimmer at 30 seconds is 2 meters per second. So at 30 seconds, speed is equal to 2 meters per second. It's just the gradient, the rise over run of that line. Whereas at 90 seconds, the gradient is, oh sorry, the rise is only 1 and the run is 2, so it's half. It's 1 over 2. Whereas the speed at 90 seconds, the speed at 90 seconds is, so the speed at 90 seconds is a rise of 2 and a run of 1. So the speed at 90 seconds is 2 meters per second. So, but in order to actually draw an accurate tangent, it's really difficult. Okay, you're always going to be a little bit off. So another method was developed, which is what we're going to talk about now, which is finding a derivative, or which is finding a tangent, the gradient of a tangent at a point, which is called first principles. So, as we know, for a curve, if you were to take the slope of tangents, they're constantly changing. Any point on this curve, if we were to take the tangents are constantly moving, and at any point you'd have a different tangent. So what we can actually find is an actual function, or a formula, that represents the slope of all the tangents on that curve. And this is what we refer to as the derivative. So, putting it in a nice, concise way, so the derivative of a function is the slope of the tangent to the curve at a point, and we write it as f dash of x, or dy dx, if you remember from last year. So, first principles formula, we're going to try and develop that next. So generally, if we consider a point on a curve, A, and we want to find the tangent on this point, okay, and let me get the highlighter. So we want to find, at the point A, we want to find what the gradient of this tangent is. Now, what we can do is, we're going to be finding another point B, okay, and we're going to be moving it closer and closer and closer to A in order to find the slope between the points A and B. Now, if we want to find the slope of the tangent at A, we'd need B to essentially be right on top of A. We'd need the distance between A and B to be infinitesimally small. So we want H to approach 0. Now, going from our gradient formula before, which was m, the slope, is y2 take y1 over x2 take x1. Well, the rise here is the difference between the y coordinates. So the y coordinate of this we're going to call f of x plus h, and the y coordinate here is f of x. So the rise of here is going to be f of x plus h take f of x. So this is our rise, and then this is going to be our run, h. So we want h to approach 0, but we can't divide something by 0. So we're going to use something called limits, okay? And so this formula here, so if we want the slope function, which is just the derivative, if we want the derivative of some function x, then that f dash of x is equal to the limit as h approaches 0 of f of x plus h, take f of x all over h. And this first principles formula gives you that instantaneous rate of change at any point on the curve. So what it does is, you have a function, you calculate its derivative from first principles. What you're finding is the slope of the tangent at that point. Or you're finding the slope function of that, you're finding the derivative of that function. And I'll show you in the next video some examples of using this first principles formula.